Hello everyone, myself Utsav Mehta. Today I am here to bring one of the best series and the important series in the mathematics, that is mensuration. Now when we come to the mensuration, what is the meaning of the mensuration? Mensu means measurement. So we are here in this chapter, we are going to talk about the measurements of many shapes from square, rectangle to trapezium, polygon, many things we are going to see in this chapter. Not only this, we are also going to look after the surface area, total surface area, couch surface area. Then we are going to look after the volume of the objects, 3D figures, 2D figures. A lot of the things we are going to talk in this mensuration series. So not only that, we are also going to explain you that how some of the formulas are derived and how you are supposed to remember that. Everything is going to be explained in this mensuration series. So without fail, don't forget to hit the subscribe button and click the notification for all, so that whenever the upcoming videos of the mensuration comes, you get the first notification and you will be the one who can watch full video without any interruption. And that also, are you the one who is going to view this whole series first? Let's check it out. Who is that? So without wasting any time and talking more about anything else, let's begin to the mensuration series. So in this series, first thing which we are going to see, that is the area of trapezium. Now, what is area of trapezium? What is the formula, or whom we identify as an trapezium? First question. So what is a trapezium? Trapezium is nothing but, you can say, a 2D figure which has a one pair of parallel sides and one pair of non-parallel sides. Definitely one pair of parallel sides and one pair of non-parallel sides. This type of structure is known as a trapezium. Here you can see the figure, that is your ABCD is a trapezium. Now how you can identify that it is a trapezium? That here I am having a one pair of parallel side, that is AB and CD. AB and CD are my parallel sides and AD and BC are my non-parallel sides. See, this is a trapezium. This trapezium, if I join the vertices A and C, then this is my one of the triangle ABC, and another triangle is ADC. These are the two triangles which have been constructed from here. Now when we talk about triangle, we also have a height. So I will drop a perpendicular line from here to here and name it as E. That means if I want to find the area of trapezium, I can see two triangles, that is triangle ABC and triangle ADC. So let us write area of trapezium equals to area of triangle ABC plus area of triangle ADC. Now we know the basic formula of area of triangle, that is half into base into height. So let us write over here, that is half into base into height plus half into base into height. Why I am writing this two times? Because both are the triangles and triangle formula remains same. Now when I talk about A, B and C, so this half remains half only. What's my base? Base is my AB. Let's write AB over here plus what's my height? The perpendicular line which I drop from C to AB, that is known as my height, that is CE, plus when I come to the next triangle, that is ADC, half remains half. In this triangle my base will be CD, DC. Yeah, base will be DC. So I'll be writing here DC. But now the question arises, what will be my height? Because I cannot take CE as my height, because that is a part of a triangle ABC. I cannot drop a perpendicular line from here because it will enter the another triangle. Now, whom I can take it as a height? So for that we can just stretch the lines, CD lines. If I stretch is over here and I drop it perpendicular over here, Then now this is a whole triangle, triangle ABC. If I stretch it over here, it will be like this. And can I name it over here F? Now this AF or FA is going to be the part of a triangle ADC, because this AF does not enter any another triangle. Your triangle ABC ends over here only, this way. But your AF is not in any other triangle. That means when I stretch this CD line from here till here F, then this AF is my height of a triangle ADC. So same way I'm taking here AF. Now why to stretch? The stretching reason is very simple, because here we cannot have a height. So if I, virtually if I stretch something, I can find my height over here. And this is not a wrong height, because I have just stretched the triangles, or I have just, holding this vertex D, I have just stretched that and I took this D to F. Now I got my height also. This height we will name it as H only. Same way, this is also going to be H only. The reason is very simple, because the distance between the parallel sides, that is AB and CD is same. Here also CE is having the same distance. Same way, if I take this CD from here to here, then AF is also having the same distance. That means I have considered both as a height only. Now, half into base remains AB, CE is my height now, plus half remains half, DC is my base, so let it write it DC only. Now AF is my height, so I write it over here height. Now if I take the things common, then half is half only over here, half is half. Then same way height are same, so I take height also outside. Now what is left inside? Half I took out, H I took, AB, in between plus sign, half I took, H I took, now it becomes DC. So from here the area of trapezium derived, that half into height, AB is my this one base, AB is the base one of triangle ABC, you can say base. Now DC is the base of another triangle. So from here, if I rearrange this formula, that is half into base into height. This is the formula of area of trapezium. That is half into base 1 plus base 2 into height is the formula. Here it was base 1, here it is base 2. So I just shifted over here. So half into base 1 plus base 2 into height. This way the formula is generated of a trapezium. In the word form, you can also say that the area of trapezium is equals to half into sum of parallel sides. Half into sum of parallel sides into distance between parallel sides. So in the word form, you can say that half into sum of parallel sides into distance between parallel sides. This parallel side is nothing. This is the sum of base, and this distance between parallel side is known as a height. So it's so simple to understand. This is the whole derivation, that how the area of trapezium came into the picture. I hope this area of trapezium, how it has been generated, that is clear to you. Yes or no? If you want to take a screenshot, please take a screenshot so that you can refer it, because I always believe that mugging up the things can be forgotten, but if you understand the things, it will last for a life. Let's begin further with our more questions, how this type of questions can be solved. So here is the first question related to the area of trapezium. We had learned or understood, you can say very well, how the formula of the trapezium has been derived from using two triangles. Now, what was the formula? Let us recall that if I talk that formula in the word form, then it is half into sum of parallel sides into distance between two parallel sides. And if I talk that same formula in the form of, alphabets, then the formula is half into base 1 plus base 2 into height. Now, this base 1 and base 1 plus base 2 is nothing. That is the sum of the parallel sides. The distance between two parallel sides I have denoted as a height. That we have seen why we have denoted as a height in the derivation section. Now, let's see this question. Question says that find the area of the trapezium whose parallel sides are 24 centimeter and 20 centimeter and the distance between them is 15 centimeter. So let us first collect the basic details from the given question. Given, we have to find the area of trapezium. So here we are going to write area of trapezium. Now whose parallel sides are given to us, and parallel side we have denoted as B1 plus B2. So this first parallel side is known as a B1. Let us write it over here. B1, which is 24 centimeter, and second parallel sides we have denoted as B2. And the distance between them, that means distance between parallel side we have denoted as height. So we'll write it over here. Height equals to 15 centimeter, and we have to find the area. So this question becomes damn easy for you if you have understand the concept that how the area of trapezium has been derived. So let's write it over here that the area of trapezium equals to half into base 1 plus base 2 into height. Half as it is. What's my B1? 24 plus 20 into 15. That means half into your 44 into 15. 2 ones are 22s are. That means 22 into 15. If I do, then what I'm going to get 300 and 330. Yes, 330 and unit centimeter. 330 centimeter square is the area of trapezium. I hope this question is very easy for you to understand how we have derived the formula, how to solve this type of questions quickly without wasting any time. Moving towards our next question. So here we are with the second question. The question says that the area of trapezium, that is 1080 centimeter square. That means here the area of trapezium is already given to us. Where else if the length of its parallel sides? So parallel sides are also given to us. The first parallel side is 55 centimeter and another parallel side is 35 centimeter. We have to find the distance between them. That means in this given question, if I write the given data, then it has been very easy for us that the area of trapezium is known to us. That is area of trapezium, which is 1080 centimeter square. Parallel sides are given, which we denote as B1 and B2. So base 1 is 55 centimeter, base 2 is 35 centimeter. Whereas we have to find the distance between them. That means the distance between parallel side has been denoted as height. So let's write it over here that we have to find the height. Now we always start solving the questions from the given data. So here the area of trapezium is given, so we'll use that formula only. That is area of trapezium is equals to half into base into height. Is this right? No. What is wrong? That your base we will take base 1 plus base 2 into height. Now it looks perfect. Now area of trapezium is known to us, that is 1080, which is equals to half into base 1 we already know, that is 55 plus base 2 35 into height we have to find. Now here 1080 equals to half into, if I add up the 60 and 90 over here, 60 and 90, yes, into height, so 1s are and 45s are. That means 1080 equals to 45 into height. And if I want to find the height, then I'll be shifting this 45 from right hand side to left hand side. That means 1080 divided by 45 is equals to height. Now let's check it out that 9 5s I can take. Then 9 1s are 9 your left. So 9 2s are and 0s are. 5 1s are, 5 2s are, and your 2 left, so 4s are. That means height is 24 centimeter. This is the whole process how we are going to find the height of a trapezium from the other given data. So I hope that this is clear how to find the height of the trapezium when the area of trapezium is given to you. So without wasting, let's move towards third question. But before that, hold on. I think if you are interested in this series, if you are interested in this video, and you feel that this video is informative, then please hit the like button, share with your friends that they can also understand and learn the things in a more simpler way. So if you have enjoyed, hit the like button and motivate me. Let's begin towards our next question. Okay, so now here we are with the third question. Let's see what the third question says. The area of the trapezium, again it is given to us, that is 405 centimeter square if its parallel sides are in the ratio. This is interesting. When the parallel sides are given in the form of ratio, it is 4:5 and the distance between them, that means the parallel side is given 18 centimeter. We have to find the length of each of the parallel sides. So whenever any datas are given in the form of ratio, then we are going to always represent this ratio with the variables. Like here I am going to take the length of the parallel side bx. Why? Because here these are not the actual measurement of the parallel sides. These are the ratios. That means whatever would be the actual answer of the length of their parallel sides, it has been converted into lowest form and it has been written over here. That is known as a ratio. Now if it is given ratio, no need to worry, just represent that ratios with the variable x. So first step, given data, if I write it over here, then we are having the area of trapezium, which is 405 centimeter square. Then B1 and B2 are given in the ratios, it is 4:5, and the height is given to us, that is 18 centimeter. So here we are going to write, let the length of parallel sides be 4x and 5x, because I told you that ratios we will always represent in the form of x. So now from the given data, let's start solving. That is the area of trapezium, which is equals to half into base 1 plus base 2 into height. Area of trapezium is also known to us, that is 405 equals to half into base 1 is 4x plus base 2 is 5x into height is 18. 2 ones are 2 nines are. That means 405 is equals to, here I can write 9x into 9. So 405 divided by 9, which is equals to 9x. Now when I divide here, this I'll get 4. 9 4s are 36, 4 left, 5s are, which is equals to 9x. So x equals to 45 upon 9, which is equals to 5. So I got that the x value is 5. Now I know the value of x. Can I find b1, which has been written as a 4x? So 4 into, what's my x? 5. So I can write it over here, 5, which is equals to 20, and the unit is centimeter. Same way, b2, which I have written as 5x. So 5 into value of x is 5, which is equals to 25 centimeter. And the question says that find the length of each of the parallel side. That means b1, which is my first parallel side, its value is 20 centimeter, and b2, whose parallel side is 25 centimeter. So I hope this question is clear to you, that how to find the length of the trapeziums when it has been represented in a form of ratio. Clear? Just remember that whenever any measurements are given in a form of ratio, you are going to represent it with x. So let's begin towards our next question. So here we are with the fourth question. The fourth question, the area of trapezium is 180 centimeter square and its height is. That means let's write the given data over here, that we are having the area of trapezium, which is equals to 180 centimeter square. Moreover, the next data that the height is given to us, that is 9 centimeter, because distance between two parallel sides is known as height if one of its parallel side is longer than the other by 6 centimeter. So here it is saying that whatever would be the length of the first parallel side, the another parallel side is going to be 6 centimeter more than that. But my first question is that do you know what's the length of the first parallel side? No. If we don't know the length of the first parallel side, then how can we say that the length of the another parallel side is 6 more? But if we don't know exact value, we cannot say. So what we can take it over here, that let the length of first parallel side be x. Now I know that the length of the first parallel side is x, then can I say that the second parallel side is x plus 6 centimeter? Because whatever would be the length of the first parallel side, the another parallel side would be 6 centimeter more than the previous. So now indirectly this is my B1 and this is my B2. Now I have B1, B2, I am having height, area of trapezium. We have to find the two parallel sides. So we need to find the exact values. So let's start with the given data, that is the area of trapezium, which is equals to half into B1 plus B2 into height. Area of trapezium is known to us, that is 108, which is equals to half, not 108, sorry, 180 centimeter, which is equals to half into B1 is x plus B2 is x plus 6 into height is, what's the height? 9. Okay. So here 180 is there. So if I multiply this 2 with 180, because this is on the right hand side, I'm going to shift it on left hand side. So this becomes 360, which is equals to x plus x, 2x plus 6 into 9. So now I will shift this 9 from right to left. That means 360 degree divided by 9, which is equals to 2x plus 6. So when I cancel, I got area of 40 because 9 4s are 36. So and 0 backside, so 40 equals to 2x plus 6. Now as I want to find x, so first I'll be shifting this 6 from right hand side to the left hand side. So here it becomes that 40 minus, because here 6 was plus, so if I 6 shift to the left hand side, it will become minus 6, which is equals to 2x. So here it becomes 34, which is equals to 2x. So 34 divided by 2, which is equals to x, that means 17 centimeter is my x. And whom we consider as x, the first parallel side, that means B1. So B1 is known to me that it is 17 centimeter. Now coming towards our B2, we know that it is x plus 6, that means 17 plus 6, which is equals to 23 centimeter. So this is the whole step how you can find B1 and B2, that means the two parallel sides from this type of comparison questions. So I hope that this question is very easy to understand, and if you like the way I had teach you this question and explain you, and you think that you are getting a real knowledge from this video, then don't forget to hit the like button. If you are new, subscribe it for the upcoming videos. Let's begin towards our question 5. So here's the question 5. Let's see what the question 5 tells us. That in a trapezium field, one of the parallel side is twice the another. That means whatever would be the length of the first parallel side, the another parallel side would be double. And we don't know that what's the length of the first parallel side. So how we did in the ratio, and or we know that whenever something is missing or unknown, we take it as x. So here we will take the first parallel side to be x, then the another parallel side would be twice, that means 2x. That means from here in the given data, we know first thing that we don't know base 1, parallel sides means B1 and B2. We don't know base 1, we will take it as x, and we will take B2, which is twice, that means 2x. Moreover, if the area of the field, and what's the shape of the field, that is trapezium, that means here it says that the area of trapezium, which is equals to 9450 meters square, and the distance between them, that is height. So height is 84 meter, and we need to find the length of the longer side. That means we need to find first of all the length of the sides, and once we know the length of the sides, then from that which is the longest one, but that will be your answer. So let's solve this. So we will always start solving from the given data. That means area of trapezium, which is equals to half into b1 plus b2 into height. Area of trapezium is known to us, that is 9450, which is equals to half into b1. Here we will suppose b1 as x because it was unknown, plus the second parallel side, that means the b2 was twice, that means 2x, into what's my height? Height is 84. So let's solve this whole question. 2 1s are 2 4s are 8, 2 2s are 4. So 9450 is equals to x plus 2x is 3x into 42. As I want to find x, so first of all I'll be shifting this 42 from right to left, so it will go in division. Okay, which is equals to 3x. Now both can be divided. Let us just check it out, that how can we cancel that 84. So 42 ones and 42 twos are 42 twos are 84. 10 left, write it over here, 10 105. If I go with 3, then it will be around 120, so it will be greater. So 22 only we will take, 2 only we will take 84, and 105 minus 84, that means 16 plus 5 19, 190. 190 is here. 84 twos are 84 is 168. So here we are going to get the answer in the decimals. So here we go with 4s are 42, 4s are 168. So 22 will be left out. So put here decimal 22, 0 over here, then it's 5s are. Okay, let's keep it till here right now. So 224.5, which is equals to 3x. So 224.5 divided by 3, which is equals to x. So now let's solve it over here. If we divide, then what we get it over here? Let's do it. 7s are 21, 1 left, then 4s are 12, 2 over here carry, decimal over here, then it becomes 8s are. Let us keep it over here only right now. So we got the value, that is x equals to 74.8 meter. That means if I take it to the approximate value nearest, so it will become 75 meter, because 74.8 is equals to 75. So I got x, and whom I have supposed x, that is b1. So b1 is equals to x, which is equals to 75 meter, and b2, which is twice, so 2x, which is equals to 2 into 75, which is equals to 150 meter, and we have to tell the length of the longest side. So therefore the longest side is 150 meter. I hope this question had become easy for you after seeing the calculation how I've solved. So this type of questions really comes in the exams, in your weeklies, to create your paper level higher. But remember one thing, the concept is same. So whatever I have explained, stick to that concept and solve the questions. You will definitely get the answer. So without wasting time, let's move towards our question 6. Now the two questions which I am going to solve, that is going to be the most important. The reason is very simple, because in this both the questions you are going to use the two different methods. Till now whatever questions you have seen over there, we were having the direct answers of all the essentials which are needed for the solving sums. Like we were having the height, we were having the parallel sides, directly it was given to us, or in the form of ratios or in the algebraic form they were given. But now over here, these two questions, that is question 6 and 7, are damn important for you to understand something new concept. Let's begin without wasting any time, and I request you to attend this both the questions fully. If you are having a doubt, just rewind and see, but those type of questions are really essential. Let's begin it. Question 6. The parallel sides of a trapezium are 20 centimeter and 10 centimeter. That means we are taking parallel sides as b1 and b2. So let us write over your given data, which is b1 is 20 centimeter, b2 is 10 centimeter. if, sorry, its non-parallel sides are both equal, each being 13 centimeter. This is something new. So for that we need to draw one of the parallel sides, sorry, trapezium. After drawing the trapezium, we need to mention all the datas over here, that is 20 centimeter. This is 10 centimeter. These are my parallel sides. Moreover, here they have given that the non-parallel side, that means this both are the non-parallel sides. And their measurements are same, that is 13 centimeter. Now this question becomes important. And they have told that we have to find the area of trapezium. Now what's the formula of area of trapezium? That area of trapezium is equals to half into base, that is b1 plus b2 into height. Half is a constant, b1 we know that's 20, b2 is 10, but what's my height? Now you will say we can find the height using the previous methods which you have used in the question, but over there, remember, their area of trapezium was given to you. Over there, the area of trapezium was given to you. Your area of trapezium is also missing. Moreover, height is also missing. And whenever we have a two missing or unknown terms in the equation, we cannot find. That means there is some role of this non-parallel sides in this question. There is some role of this non-parallel sides in the question. What is that? So let's crack that secret, how to solve these questions. See, this is the figure. Okay. If I draw a parallel side, let us name first A, B, C and D. If I draw a parallel side to AD, then where I'm going to draw that parallel side to AD? This is my AD. If I want to draw the parallel side, then I need to draw this way line, slant line, which I'll name it as, E. That is, name it over here, E. So I have drawn one of the parallel side to AD, that is CE. AD का parallel side हो गया CE. अब अगर वो parallel side है, then if this is 13, then this is also going to be the 13. Okay, that's true, right? Parallel sides are same when they are, because distance between are same. So this is 13, CE is 13. Now you can see that here one triangle is formed, that is CEB, or you can say BCE. So in this triangle BCE, in this triangle BCE, what's the formula of the area of triangle? That is half into base into height. This is the formula. But we have to find the area of trapezium. We don't need this formula. So what we are going to do? We are going to erase this formula. But we'll be taking this triangle, that is BCE. Now, if I draw a height over here, let us take this as a F. If I draw the vertical parallel line dropping from the vertex C to the line AB, that is going to be my height, and which I need. How can I find? This is a triangle. Can I use the Pythagoras theorem over here? If I take this only as a triangle, this is a triangle, then this is a right angle triangle, and right angle triangle we can use the Pythagoras theorem. That means BC square, hypotenuse square, equals to perpendicular square plus base square. This question is really very important. BC is known to us, that is 13 square. CF we have to find, so let us keep it as CF only, which you can take it as height, plus FB we know. Now what's FB? How can we find it? If this whole is 20, if this I use it as parallelogram over here, I draw the parallel side, then this much is going to be my 10. And remaining is going to be my 10. If this is 10, I am dividing this 10 into two parts, each becomes of 5. It becomes of 5. That means my BF or FB is 5 square. That means height square equals to 13 square minus 5 square, which is equals to height square equals to 169 up minus 25, which is equals to 144 height square, and height equals to square root of 144, which is equals to 12 centimeter, 12 centimeter. Now I got a height. Now I have got a height. So now height is known to me. Can I find area of trapezium very easily? Definitely. What's the formula? Area of trapezium equals to half into B1 plus B2 into height. Area of trapezium equals to half into what's my B1? B1 20 and 10. So 20 plus 10 into what's my height? Height 12. 2 ones are 2 6 are. That means 30 into 60, which is equals to 180 centimeter square, is the area of the trapezium which we were finding. See, it's so simple, no need to get more confused. First of all, whenever height is not given and area of trapezium also you need to find, then and the measurements of the non-parallel sides are given. We will draw one of the parallel side. Measurements are same. Then we'll take that triangle. We'll use the formula of Pythagoras theorem. Pythagoras theorem, that is hypotenuse square equals to perpendicular square plus base square. Using from that method, we will find the height, and that height we are going to use it over here. This is easy. It looks difficult. Just you have to apply the Pythagoras theorem. Take a screenshot, rewind it once. Just see how I have drawn. If you have any doubt related to this question, then comment it. Definitely I will solve your doubts. Definitely. So let's begin with the another important question, that is question 7 in this video. So here I am with the 7th question. This question is important. It is different from question 6. And this question has a lot of informations. And to solve this, we need to also understand one of the formula which is new for you. So stay till the end of this question so that you can learn new things. Let's begin it. The parallel side of a trapezium are 25 centimeter and 11 centimeter. That means let us draw the trapezium only first of all. Okay. I am having one trapezium whose parallel sides are 25 centimeter and 11. That means this is going to be my 25 centimeter. This is going to be my 11 centimeter. Okay. While its non-parallel sides are 15 centimeter and 13 centimeter. That means this is my 15 centimeter and this is my, you can say 13 centimeter. This question is different from previous. In the question 6, they have told that the non-parallel sides are there, but their measurements are same. Both were 13 centimeter. Here again non-parallel sides are there, but their dimensions, their measurements are different. So this is a different. Over there we had used a Pythagoras theorem. Why? Because over there the two sides were same in a triangle. Here, let's see, are the two sides same in this trapezium, the triangle which you are going to create to find the height? Let's see that. Because here, you know, non-parallel sides measurements are different and we have to find the area of trapezium. We know to find the area of the trapezium, the formula is half into B1 plus B2 into height. Half is a constant, B1 and B2 is known to us, 25 centimeter, 11 centimeter. But what about height? Still it's missing. That means height is the vertical line. This is my height. Let us name this as A, B, C, D and E. Let's solve quickly. As I told you in the previous question that if height is not given, we will draw one of the parallel side to one of the non-parallel side, that is AD. I am going to draw the parallel side to the AD and this is going to be my side. which is going to be CF. So AD and CF, AD and CF are parallel sides and the measurements are going to be same, that is 15 centimeter. If this is my parallel side, then if I put my hand over here, I don't want you to see this part. This is a parallelogram. And in parallelogram, the opposite sides are same. That means if DC is 11 centimeter, then AF is also 11 centimeter. If DC is 11 centimeter, then AF is also 11 centimeter. Why? Because if I keep my hand over here, I don't want to see this, then it is a parallelogram. And in a parallelogram, the opposite sides are same. Now this is 11, total is 25, this is 11. If I subtract, then I am going to get 14 centimeter as this whole. That is BF is 14. If I divide it into two parts, this is my 7, this is my 7. But in the sixth question, we were having in a triangle two sides same. So we used over there Pythagoras theorem. But in this case, 15, 13 and 14. All the sides are different in a triangle. This is a scalar triangle. Now, if this is a scalar triangle, then how you are going to find the height? Here, you cannot use Pythagoras theorem because here all the sides are different. So over there, when such type of things comes, we are going to use the formula, that is Heron's formula. What is this Heron's formula? Heron's formula is a formula which we basically used with the scalar triangles, and this is the concept of 10th. Heron's formula is nothing that side equals to A plus B plus C upon 2, and the area of triangle equals to square root S minus A, S minus B and S minus C. Now what is this S? Sides. What is this A, B and C? A is the first side, B is the second side and C is the third side. Let's solve that. How it has been done? So S equals to A plus B plus C divided by 2, which is equals to, what's my A? 15 plus 14 plus 13 divided by 2, which is equals to 9 and your 12. 1 carry 3 and 42 divided by 2, which is equals to what? Which is equals to 21. 21 is my S. Now we are going to find the area of triangle, which is equals to square root S minus A, S minus B and S minus C. Your area of formula, we can also write it over here, that is half into base into height, which is equals to this S minus A, S minus B, S minus C. Why I am writing this formula? Because I have to find height. Now half into the base of this triangle. The base of this triangle is 14. So 14 over here into height as it is. What's my S? 21 as it is. 21 minus A is 15. 21 minus B is 14 and 21 minus 13. 1s are 7s are, that means 7 into height equals to 21. If I subtract, I'll get here 6, 7 and 8. Let's multiply this whole. On multiplying, what we get? That is 21. 6 as it is. 8 7s are 56. When you multiply this whole, you are going to get the answer 7056. And if I take the square root of this, I am going to get 84. 7 into H. So H equals to 84 divided by 7, which is equals to 12. And what's the unit? Centimeter. So I got the height, that the height of a trapezium. Height of the trapezium is 12 centimeter. It looks difficult, but it is not so. You just only have to remember that if I'm finding the height of any scalene triangle, at that time I was supposed to use the Heron's formula, which is S equals to A plus B plus C divided by C. A plus B plus C is nothing that are the different sides of a triangle, and area of triangle equals to square root S, S minus A, S minus B, S minus C. In short, in the scalene triangle, when you are supposed to find the area of a triangle, you are going to use this formula. Now I got a height. Now I'm going to erase this diagram so that we could find the area of the trapezium. Now we know the height. That's why. So when I erase, we will be solving over here. That is the area of trapezium, which is equals to half into B1 plus B2 into height. So half as it is, base 1 is 25 plus base 2 is 11 into height. I recently found that is 12. 2 ones are 2 6 are, which is equals to 36 into 6. When I do this, I will get that is 18 plus 36, which is equals to 216 centimeter square is the area of trapezium. I hope this question is somewhat beyond the level of the regular, but it's fine. You had learned something new, that how to find the area of the scalene triangle. So I hope that this question is something unique, something new you had learned. And if you really enjoyed this, or you found something new in this video, then hit the like button, motivate me. And if you're new, don't forget to subscribe my channel. So we will keep this video till here. In the next video, we are going to look more in this mensuration series. So without any wasting time, goodbye, have a nice day, see you soon in the next video. Bye everyone.